Okay, so today I'm going to teach you how to graph a polynomial function if there are repeated zeros. So I'm just going to teach that by an example. Okay, so this is what we're going to graph. X to the 5 plus x to the 4 minus 5x to the 3 minus x squared plus 8x minus 4. So of course, we're going to find our zeros. I tried 1, it became a 0. I tried 1 again, so that's possible. That one number will give you a 0 twice. So that is already a repeated 0. It's repeated twice. Okay, and then we continue. So that's -2. It will again give you a 0 until we reach this x squared plus x minus 2. And we can just do regular factoring, x plus 2, x minus 1. So let's write all our function in factored form. So this will be x minus 1, x minus 1 again, x plus 2. Then we write these two factors, x plus 2 and x minus 1. So we have 5 zeros, but actually there are only two because these are repeated zeros. So 1, let's write it without repeating the numbers. So we say our x-intercepts are 1, but it is repeated 3 times. So we will use this term multiplicity, or meaning to say it's repeated 3 times. So the multiplicity of x equals 1 is 3 times. Now try to remember this. This is an odd number, 3. So 1 is repeated 3 times, an odd number of times. And -2 is repeated twice, or so multiplicity of 2. Okay, then let's continue. Y-intercept, make x 0. So y is -4. And behavior, leading term is 1x to the 5. So that will be down, up. So now how do we graph this? Okay, so our x-intercepts are 1 with a multiplicity of 3 and -2 with a multiplicity of 2. Now I suggest if the multiplicity is an even number, let's just use a strategy of instead of a circle, let's do like a small square. Just to remind us that that is multiplied an even number of times. Even number of times, 2 times, 4 times, 6 times, 8 times. Those are even number of times. Okay, doesn't look like a square. All right. So then -4, let's say this is -4, so we're going to mark that too. All right, it is, and behavior is down, up. Okay, so it's going to be down here and up here. Okay, down, up. So when the multiplicity is even, okay, so we're not going to touch it, or we're not going to cross. We're just going to touch it and then go back, okay, below the x-axis. Or if you are above the x-axis, then you stay above the x-axis. And then we're going to cross here and cross here. So let's say something like this. Okay, something like that. Okay. So our takeaway here is, if this is the new lesson, right? If the multiplicity is an even number, you do not cross. You just touch, or some students say you bounce. Okay, because the multiplicity of -2 is 2. and this one has a multiplicity of 3. We are not worried about multiplicity when the multiplicity is odd. We just do what we've been doing before. We just cross. The only new thing is when the multiplicity is an even number, you do not cross. You just touch it. If you are below the x-axis, you stay below the x-axis. If you were above the x-axis, then you stay above the x-axis. You do not cross. Okay, so let's finish this summary. We said, okay, x-intercept, just write it, y-intercept, extrema. Okay, so we don't have an absolute max, none. We have a relative maximum point, okay? So in this hill here, we have a high point, but we know exactly where is that high point, okay? So there is no higher point in this area here. So we do not say in the interval. Instead, we said the point -2, 0. So we are sure that that is the lowest point, the highest point in that area. And then we have no absolute minimum. Then we have a relative minimum. In somewhere here, there's the lowest point between -2 and 1. We don't know where, so we say in interval between -2 and 1. Okay.